All right, hello everyone. In this kind of first major section that we're going to talk about, we're going to discuss linear regression. So, modeling a quantitative response with a quantitative predictor. Talk a lot about the basics that'll kind of help us build up to more complicated models in a few weeks. And so to kind of start, we're just going to talk about this really general framework for kind of thinking about models. And so we're going to frame it in this four-step process where the first step is just to choose a model. And so from the get-go, that's kind of easy enough because we're just going to have one response and one predictor. So that's going to be the model that we're going to choose. We're going to fit that model using statistical software. And in particular, in this class, we're going to use what's most common among statisticians, and that's using the statistical software R. Then we're going to assess the model's assumptions. And so just like the tests that we did in Interstat, this simple linear regression model and the models that we fit in the future are going to have certain assumptions that we're going to need to check. And then we're going to use the model results. And we're going to use it either for inference, and so that would be like confidence intervals and hypothesis tests, or we're going to use it for prediction. So to predict, the response of some maybe future observation. A last little bit of review from Stat 113 that's going to help us in a second is we're going to remember the definitions of parameter and statistic. And so a parameter was just some characteristic of a population. And this was usually, in most practical problems, unknown or theoretical. And so to kind of jog your memory a little bit, some examples that you might have seen before of parameters are mu, which was the population mean, p, the population proportion, or sigma, the population standard deviation. A statistic, on the other hand, is some characteristic of a sample. And this was usually calculated from actual data. So we go out and collect a sample, and then from that sample we could calculate certain statistics based on that sample. And so some examples that you might have seen before are mu hat, or x bar for the sample mean, p hat for the sample proportion, or s for the sample standard deviation. All right, so before we really talk about the model basics, let's briefly discuss the example that we're going to use, at least for the first part of this note packet. And so the example covers some baseball data from the 2011 regular season. And so we've got observations on each of the 30 professional teams in that season. We've got the number of runs that each team scored, and we've got a couple of candidate predictors. So we've got the batting average for measuring at-bat performance, and we've got this new OBS, which is some on-base slugging statistic. And so if you're not really into baseball, that's totally fine. It's not super important to know exactly what these are. But the motivation for this problem comes from the kind of Moneyball book and then film that came from the book. And so the idea is that in this handout, we're really going to focus on batting average, which was kind of this older metric that was used by people to draft players on teams. And then in a handout that you're going to do on your own, you're going to compare that predictor to kind of what the model would look like if you used this kind of newer predictor for runs of a team. And that this predictor is this on base slugging statistic, which kind of is described in this paragraph if you want to read about it. I myself am going to actually watch Moneyball finally over the holiday break. So this video is being recorded before the holiday break. So I will know a little bit more about um, I guess, the details about this example, hopefully after I watch the movie. Okay, and so we'll kind of wrap up there and kind of pick up where we left off with introducing the simple linear regression model in the next video.